Looks like we're ready to go. It's Tuesday night, April 26, 2016, and it's Tuesday night, so therefore it's Keshe Plasma Reactor Group. Or at least it has been for me for the last 3 years or so.
Rick,
And
it looks like the cloud recording didn't take.
didn't take, indeed. Oh,
There we go.
is it taking now?
It seems to be now, yeah.
Oh, that was funny. Okay, retake and all that. It's Tuesday, April 26, 2016. Because it's Tuesday, it's Keshe Plasma Reactor Group, and we've got Mr. Coates chewing at the bit here, ready to go in his driver's seat. And speaking of driver's seat, that reminds us of Canadian Tire somehow. So tell us about what you have there, Lee.
Well, I liked your idea of last week about the fan ball spinner, so I grabbed one of those and trying to make the the dome protection or whatever.
Let me show it before the. I'll
Yeah,
show
go
it.
for it.
I'll show the before picture. This is what it's supposed to look like when it comes out of the store. I've got mine set up. I've got a GANS ball inside there. I don't think you can quite see it through there, but here it actually is spinning there now. But Lee has taken it to the next step, I think, here. So let's have a look at that.
Well, this way you can interchange the balls easily. So
Yeah, right. I had considered cutting a hole in the top, but I didn't consider cutting the whole top off.
so I had 6 different combinations of GANS I've been trying this last couple of days, and
Oh, excellent. How do
still
you?
haven't noticed anything. But
You're using a regulation ping pong ball, I take it?
it's a Canadian Tire beer pong ball,
Oh, okay. Well, that must
and
be
it
as
and
regulation as it gets.
it just doesn't quite fit, so I had to wrap a couple of layers of masking tape around the ball, and then
Oh,
it's there
maybe
nice
it might.
solid.
There's two different sizes of ping pong balls, a 38 and 40 millimeter, I think they are. So, okay. And how do you
Yeah,
fill it?
I had some. How do I fill it? I
Yeah,
drill a
huh?
hole in
In
the
the top.
ping pong ball, and then I got a glue syringe which I squirt the stuff in with,
Yeah, and
and I
then.
nano coated the balls first by filling them with caustic soda, and then
Mm-hmm.
rinsed them out, and
Okay.
then I put various ganses in there
And how do you seal the top, or do you?
with that marine goop.
Goop. Okay, good old goop. Yeah. Also found at Canadian Tire. No.
Yeah, or wherever. So yeah, so there's a
Yeah.
little wee hole there with marine goop on it, but
Okay, that is really good stuff. It hardens up over time, and
it it sticks to the ping pong ball anyway. Because I tried another glue first and it peeled right out. Or actually, I started to spin and it started squirting water at me.
yeah, right. There's I've tried a
So
number of different glues on ping pong balls, and some are successful, some aren't. Goop is the best I found actually when gluing onto some sort of suction cup type of shape or something like that. The
yeah.
goop works really good.
So I got it set up with to my power supply, so I can vary the voltage on it. And I also screwed a piece of plywood on the bottom just to make it stable.
What kind of power supply do you have? It's a variable voltage for 12 volts.
Oh, it's oops,
Oh,
what
okay.
happened?
It's a real power supply. Okay.
I lost the picture there. What happened?
No, still happening here.
I must have clicked something. I'm off Zoom.
We're okay
There we
here.
go.
Okay,
Yeah, we're
there we
good.
go.
I must have clicked something and
Okay.
lost it. So, so I've been varying the voltage on that. Like, if you want some specs on the RPMs on that, I had an RPM
Sure.
meter.
Yeah, that's a good idea. I was wondering about that. I know it goes pretty fast without the ping pong ball.
I don't know whether that's visible or for the
Yeah,
record or not.
yeah, just hold it steady there and it'll focus in yeah. We can see that down to 22 volts. And
Yeah, I
now,
only went to 24,
and
but
then you hold it up a little bit. So 24 volts is 7220. I don't know how long it'll last at that RPM, but
No,
so
yeah, that's right. I just
standard 12 volts or so is about 3000 RPM.
yeah, and
But you have unstable. What does that mean?
it was I went into a resonance vibration there.
Oh,
So
you
and that
mean
may have been just for that particular ping pong ball I had in at the time,
okay?
but
Yeah.
but it slowed it right down.
Okay, so even 5 volts gives considerable RPM. It's that could be
Yeah,
almost a USB voltage, for example, and do 1500 RPM.
yeah. So it's I mean, Keshe told us to spin it pretty fast, but what do you figure is fast?
Well, when did he say pretty fast?
Well, when he was explaining this, he said, "Spin the ball fast."
Yeah, but he's also said don't spin it too fast. So what is the compromise? What I found it's quite interesting actually. If you were to have a clear sphere that size and watch the action inside the sphere when you have say maybe 10% air inside, so you have that air bubble. Do you have an air bubble at the top, or is it filled
I got
right
a
up?
I got a hydrogen bubble.
Ah, okay, even better,
Yeah.
perhaps.
Yeah,
Um,
yeah, yeah. So I put in a little bit of lead GANS in, and then I've been trying various combinations of CuO and brass GANS and CH3 and some titanium oxide GANS and some aluminum GANS, and then I
okay.
had some tin can GANS, which I think was mostly CH3. But
And so you're putting in the actual GANs, not the GANs water as
no, I'm
such.
putting
Or
in GANS water.
okay,
Sorry.
I see. Just the pure GANs water. You have
Yeah.
so when you spin it, you don't see any ring that forms around the edge or whatever when
No,
from the.
these orange balls, I don't see anything, and
You
I haven't
hard
tried
to
with a
tell.
flashlight to look through them or anything. So
Right. So back to the question about the speed and this thing of the little tube that forms from the air pocket in there. Say you have maybe I don't know 10% air, just a little pocket at the top, or in your case hydrogen or maybe argon or whatever one wants to work with. Um, so when that spins, it starts to form a cylinder in the center, and eventually it forms kind of a what would you call it? You can turn it sideways, for example, and it no longer forms that funnel shape. It then forms sort of a cigar in the center of the sphere. And if you, for example, rotate a tube, not a sphere, but a tube with an air pocket in it, the air pocket will form in the very center, and it'll will elongate exactly according to the RPM. So the faster you double the RPM, and that bubble will elongate twice as much, basically. So it's really interesting that at very high speeds it forms that tube in the center, but at slower speeds there's more circulation happening. There's more of a vortex effect that goes up the sides and down the center, and it keeps circulating that way. But with the very high speeds, there's more separation. Everything is pressed out to the sides and pretty much forms a more what you call it, stratified layers in between. So at the lower speed, I think it's more critical to form it at the lower speeds where there's still some centrifugal, that gravitational force that's acting on everything, but at the same time there's a certain circulation occurring. So, and what is that magical speed? Well, for some of the reactors back in the earlier times, it seemed to be around somewhere around the 1,000 to 2,000 RPM range seemed to be a sweet spot sort of range. And that's what I found with experimenting with just trying different RPMs with something clear that you can see what's going on. But That's debatable. You've got quite a combination there with the lead GANs and so on. It might be that having the more extreme separation at a higher RPM might be called for.
Yeah, so far I've only tried it around for steady around the say 14 to 16 volts, so in the 4000s, which I don't know whether that's too high or too low or whatever. So
Well, the GANS water itself is a different ball game, so to speak, with the instead of the GANS itself, which was last year we did a lot of experimenting with the rotating the GANS balls with different layers of GANs in there, and they would separate out. You would see the different colored rings and so on that would form. But with the GANS water, what could we see even with a clear container? Do we see layers? Will there be a layering effect? Or if there is, will we see it? I guess that's one question. And
I don't think there's going to be a layering effect, Rick, because when you're dealing with the GANs, especially different kinds of GANSs, you'll have various different masses in there, which are going to stratify with the centrifugal force. But when you're dealing with the GANs of water, it's all the same mass. So it's going to order itself by the plasma strength rather than the mass of the material.
Interesting. Maybe it's easier for it to order by plasma strength because it's all the same mass of material even.
Yeah.
Because it's mobile in that mass.
The GANS water and the actual GANS itself is the GANS water. It'll allow a lot more movement of the fields. They won't be locked into position by the centrifugal forces.
And they're also acting as if in a vacuum inside the fluid as well. So have you noticed any effects with the different kinds of GANs or anything else there, Lee?
no, I haven't noticed any effects. So that's another reason I wanted to talk about it, is just wonder if anyone else has been doing this and what they've found.
Yeah, and the thing is, it might have to run for, days or weeks or something in order to build up fields and so on, for all we know.
Yeah, I've had one ball run for about a day, and then the rest I've just run for a couple hours each, kind of thing. So haven't really let it run too long.
Is it running quite balanced and quiet with the ball filled up? I haven't filled mine yet. But...
Yes, it is. I'm surprised. As long as you keep your glue spot on the top, and that's why I have to wrap the masking tape around it. Otherwise, the glue spot would go off to the side, and then it would get unbalanced. But you got to keep the glue spot on top, and then it's pretty well balanced. It's surprising that fan is really good for being balanced.
Yeah.
So, and then if it's out of balance a little bit, you can just rotate that glue spot just a little bit, and you can get it in balance. So it's quite a good spinner.
I guess I'm going too small. My glass spheres are about 5/8 of an inch diameter, and my motors come out of one of those little $20 helicopters.
Yeah.
But they're like these little motors. These are like 10 or 12,000 RPM motors. They're really, really potent for the size. I mean, they're 1/4 inch diameter and about 3/4 inch long. And with bolts on it, it's hard to stop it. It'll burn your fingers before you'll stop it.
Yes, I know. They're quite powerful and fun to use on a contraption like that, as long as they don't overheat over extended time. So
yeah, but I'm having a hard time getting these glass balls mounted, trying to find something to mount them with.
Well, your balls just have a hole in them, don't they? Like a stopper hole. There's no neck. Is that right?
Ooh, wrong button. Yep.
Just trying to see.
It's like a 3 millimeter hole in the bottom of the.
Right. Yeah, I've got some like that as well, and the ones I was using. Here, let me highlight your video so people can see that.
Now I gotta focus because it's big.
Yeah. Well, you got your beard good.
Well, there's the little
nice focus. Yeah, Beautiful. Yeah. So you got a tiny little shaft there, about was it a millimeter or something shaft, and
Yeah, even less.
it's got a gear on it now, right?
Yeah, well, these are, I just pulled these ones straight out of the helicopter, and I've got a couple other
Okay.
ones from a model car.
Right. So will the
With a
gear
little,
fit in the hole, or is it too big or too small?
let me pop one of these off here. I'll show you the.
Okay, the gear is smaller than the hole. Okay.
But I'm thinking if I can get a hold of a lathe for 20 minutes, I'll get a bunch of golf tees and I'll cut them and I'll drill them so that they're true. And then I can just glue it onto the golf tee. But I don't have access to a lathe around here.
The other thing that some people are doing before was JF, JF DuPont. He has a 3D printer, and he was printing off little golf tee shaped things with the right size hole so it would fit the shaft.
Yeah.
Be
The one thing I
pretty,
was working on was the wheels from the model car.
yeah,
And this is one of the front spindles that
yeah,
if I take the antenna tube that you put over the little wire antenna,
yeah.
it just fits inside the spindle, and that's a fairly nice tight fit on the motor. And then I can
Mm-hmm.
stick the wheel on there, and the ball will fit in there nice.
Huh.
But that's kind of there's a lot of
Kind of
mass
over.
there. It's going to slow the motor down a lot.
Yeah, you could take the tire off the wheel perhaps, but
Well, I just what I do is I stick it's I can grab that on my drill,
mm-hmm.
snip these off around here. So all I have is the inner hub, and then take a
You
file and
file
file
it
it back.
down. Sure. Mm-hmm. Well, here's a solution I had with mine. Um, these balls have little. Oops, where did we go there? These balls have little spigots on the end, so they actually can. I've actually got them set up so I can. Let me get this set up here. I can remove it from its holder, and this has a little hole in the end with a screw thing that goes in. A screw cap goes in the end, so they can be filled. Let me get my focus here just a minute. I have to do a magic focus thing here.
Yeah, I had to do manual focus. That's the only way it works.
Where are we? Auto off.
Gotta love these autofocus cameras.
There, something like that.
Oh yeah, okay.
So you can see the, oops.
Does the
Finally get it
volume-
focused and I lose
Does
it.
the extra in that spigot cause you any issues?
The which?
The extra volume in that the little nose on that ball?
Don't know if that causes issues or not. When it's in this position, all the fluids go down, and when it rotates, the GANS is just around the ring, around the middle here. And then once you have that established, you can put it in any position and it'll hold. So what I did was I had this little setup just for fun. And like I said, putting these units, this is a, excuse me, this is a rubber tube that goes through to the other side. These are filled GANS bulbs here, 3 of those. And on this side, I just started playing around with this side. So that just fits right in there, presses in, real nice. I've got 3 bearings here. Okay, now the way it all rotates is I've got a separate motor, like a airplane type motor with the speed control and so on. And I just use a rubber belt, an O-ring, that goes around these 3 plastic tubes and is attached to the motor shaft over here, like. And all 3 of these will rotate at once, so that actually all 6 of these GANS reactors can rotate at the same time. So it's interesting kind of configuration that one can make with it, set up something like this with under and over configuration. So I was playing around with that a little bit to see what might come up with for some kind of different, like if these were different gradient, maybe the lead GANs on one side and CH3 GANs on the other or something. So we got a bit of interference here. Thank you.
There we go. Yeah, if worst comes to worst, I'll just dig out my 25,000 RPM rotor and use that for a motor. It's a little noisy, but it works.
Yeah, right. There's lots of little motors they have nowadays with the radio controlled devices that are so cheap and so on too. That's
yeah, and most of those motors, they're good for 20 to 25,000 RPM. They can go amazingly.
Yeah, I've had to gear down some of them because they're just too fast, and you don't want them to be. You don't want your things to be spinning that fast generally.
Yeah, well, with the pulse modulated speed control, you got 0 to day or DC to daylight basically with the speed on those motors.
Yeah, except the motors that are designed to go at 25,000 RPM don't put out much torque at 3 or 4,000 RPM, for example. So they come in different categories according to the voltage makes a certain RPM. So you'll have one that's an 800 will give 800 RPM, while another one will give 1200 RPM or 2000 or whatever from the same voltage. So it's good to get one that's lower voltage but still has the amperage sometimes to compensate.
Yeah, they rate those things very strangely. The number, like you get a 1200, it's 1200 RPM per volt.
Right.
Which is, they're not rated like regular motors. It took me about 6 months to figure that out.
Yes. Yeah, it's totally bizarre, but and then when you use them, sometimes with the pulse width modulation, they can start sort of getting jerky or noisy if they're not in their range that they like to run in and so on.
Yeah.
So, yeah, a lot to that. So, Lee, you have a 12-volt power supply it's not a pulse width modulated, it's just a regular type power supply, I guess. That seems like a good way to regulate the speed, because you can tell exactly from the voltage and so on where you're at. Mine, on the other hand, I have to just sort of guesstimate 12 volts in my system here. I've got other means of, I did have a pulse width modulated system with 12 volts that unfortunately burned up with one of my motor combinations. That's the other thing that can happen, is you can overload your PWM pretty easily with some of these 100 amp motors and so on.
Yeah, they're pretty cheap though. You can get them off eBay for $4 and $5. I mean, I bought a 30 amp to run my electric scooter for $7. And so and that works really, it worked really good for like a little tape deck motor. Drove it nicely.
Mm-hmm. Okay, Lee, anything else you want to show or tell about that unit, or anything else you'd like to talk about right now?
Yeah, I think that's it for this unit.
All right. For this unit, you're teasing us. You have more you want to show, perhaps?
Well, I don't have the camera set up, but you know, the Q12 I showed last week.
Oh yes.
That they were setting it up from a car battery through an inverter to the Q12, and then running a load off it, and they were getting more power out than they were putting in. So I said, "Hey, this is great. I'm going to try that," but I can't. Mine doesn't work. It wasn't charging up the battery like the other guys were doing. So my experiment failed. I don't know why, but maybe everything isn't nano-coated yet and stuff like that. But
do they have a bunch of plasma batteries they have incorporated into the unit that might be putting extra power in?
Well, the Q12 has 12 plasma battery capacitors.
Mm-hmm.
So that's why they call it not a 12, sorry, 24. That's why they call it the 24, as opposed to the 6 has 6 of them. The 24 has 24 of them. The 144 has 144 of them.
I see.
So That's the different cues.
Well,
But it was an interesting concept because it was basically you had a generator, you know.
right.
So I'm going to keep working on that and keep trying to get that one working.
Okay, great. That sounds good. Sounds like fun.
So I was just wondering if anyone else had tried that.
Yeah, what have others gotten into here? Let me check the live stream too, see if we have any responses there. Okay, so what have other people been up to in the last while, or any? Whoops. Stop that. Okay, somebody wants the Zoom number, so I have to get that to them. Yeah, who's got something they'd like to show and tell here today? How about you, Libby? You got anything you have going nowadays?
Well, I did the ping pong balls, but in my own way. I did them on a clothesline, and I don't think there's enough spin on them. But I have a picture I can put.
Can you show that? That'd be great.
Yeah, sure. Hold on
Thank
a
you.
second. Yep. Get that up right here. So that's three of them. I wrote love on the outside of them. They're in different. Can you see it? Okay.
Yes.
Okay. They're in the major ratio was CO2. Then I use CH3 and CuO because that's basically what I have the most of. Actually,
So
CH3 I have tons of.
different
And
ones in each ball. Like each ball is a separate
no, they're
GANS.
a mix.
Okay.
But the mix, I was learning here. I'd never actually used a syringe before, and it was a pretty small syringe. And so the first one has probably, if I'm lucky, half full. The second one is probably three quarters full, and the third one is full. And that actually made a really nice play when the wind was blowing, because they would be doing what like they're showing in this photograph. They're kind of juxtaposed in a good way. And to the left of that picture, there's a really nice cedar picnic table, and I would sit on that and meditate, and I love to do it. The ambiance is fantastic around it. Now it is spring, but there's so many birds around. I keep thinking, I wonder if they're going to try to tug this and put this in their nest. But and my cat likes to sleep underneath it or in that area. So something good is happening. What is happening? Obviously, my GANS water weren't pure water because on each of the bottom of these, there's a ring of CH3 now. Um, so it's. I realized once again that because I'm shy about motors and electrical stuff, this is probably limited. But what I did do, that's a piece of wool that's got a
Oh.
knot, and I stuffed that in the hole and then covered the whole thing with glue gun stuff, which
Oh.
I wasn't sure would hold, but this is now, I think, 3 or 4 days later, and it's working. Nothing's come apart. And I left quite a long string before the knot I made so that if the rain comes and if the wool allows itself to go through the glue, then it would keep feeding water into the system.
Wow.
But,
What a
but
concept. Yeah, that's
yeah, it's a
great.
concept. Whether it's got validity or not, I have
Uh,
no idea.
or will it go
But
the other way? Will it tend to dry out the GANS inside by draining it somehow?
mm,
Interesting.
well, that isn't. I also saturated the wool in the same waters.
Okay.
So I think,
Well,
and the wool does conduct. I mean, it's a really good conductor. So,
yes. Well, it's wool is. It's also it's special in terms of electrostatic forces. They use wool to. Is it the positive or negative charge that wool encourages? They use wool to rub on say a plastic sphere or a glass sphere in order to put charge on it.
Oh, I didn't know that. Thank you.
That's
Anyways,
in fact, that's where the first plasma ball. Oh, I don't have my picture. Oh, there it is. Hang on a sec. Check
just stop
this out.
sharing.
This is from. Let me. Yeah, just for a minute here.
Okay, let me
Let
let
me.
me do that again. That's the part that I mess up on sometimes. How do I get in there? Ah, sorry.
I can.
Right.
Maybe it's at
Good.
the top. Sometimes it disappears.
Yeah, it's totally dis. Oh, there it is. Okay.
Good. Thank you.
Yep.
And let me spotlight my video. I'll show you this picture of the Hawksbee device. It's called. Okay. So what this is the the
Cool.
first form of electricity in the modern world, supposedly in the West or whatever, is we've got this guy over here. He's cranking away at this crank, right? To crank this pulley that rotates a sphere. This is a glass sphere here. Okay, and this woman this woman here is putting her hands on this glass sphere while it's rotating at a fairly high RPM with this guy cranking away on it. Okay.
Wow.
This is back in the 1600s, before they even had batteries, electricity, or anything else. And what would happen is the sphere would start to glow. It was partially evacuated, and they had found out that a partially evacuated sphere, when you rotate it, will glow. It gives this purplish kind of glow. And so they actually did this for entertainment. They would go around from town to town and show people and wow them. And eventually, people had these in their homes. For the rich, they would have the slave of the family, rotate the device, or someone would do that, and while the wife would light up this globe, and maybe the husband would read his newspaper or some other, form of entertainment by having this light bulb glowing. And it was so early that they didn't know what to do with the electricity because they had no storage batteries and no way to contain it or to transfer it. So all they could do is have it in the moment, rotate the globe, and make the light. But it's very interesting that way back, that was it's a plasma globe, and it's one of the first forms of light and electricity in the modern, so-called modern world. They may have had it back in the days of the pyramids and previous to that, but in fact there's good evidence that they used plasma globes in the pyramid days. But what you have there, if you want to just show your picture again there, Libby, just briefly. Yeah. So what you have there is three plasma globes on the end of what they used was a piece of wool too when they spun these globes, and to try to light up the globe with it. And I've actually tried that as well with rabbit fur.
Hmm.
Rabbit fur works as well. I've lit up a ping pong ball with this effect actually. You turn it
Well, there
really
are
fast.
moments where it feels like there is bright light coming from it, and I've gone out at night to see if that's true, but I haven't seen it. Um, I also understood, and I may have misunderstood because I'm good at doing that, um, that Kesh had said that we could place these balls outside. And so that's why I was encouraged. I thought, okay, clothesline now. I recognize it's probably better to get them in a more triangular shape, but you can see with the way the wind blows, because they're not the same weight and they're about 3 feet apart.
How long are
Um,
the strings for them,
they're
approximately?
different lengths.
A couple of meters, or
Oh, no. Give me inches instead if you can. That's okay.
okay, like 3 feet, 4 feet, 5 feet.
Oh no, less. 2.5 feet, maybe 2 feet.
Okay. Mm-hmm.
Yeah. And I I was considering just because I'm asking them to change the area around here, protect the area, fill it with love, and the drumline above, below, and then outwards to all of Nova Scotia. Um, so I'm wondering how many more of these I might need around to to make a good thing for the planet. But it is fun, and if I wasn't moving, I would have probably covered the whole property with these. But I think that I might still do that. I'm not leaving for another month, so just to see the effect. The effect I've noticed is that there's a lot more birds in the area, and my cats are really enjoying being underneath it. And I love sitting on the picnic table and meditating under it. Seems to amplify the energies.
Hmm.
So that's my
Interesting.
experience so far.
Yeah, I like the idea of the wool string. I think even is that what? Trying to think back to Ben Franklin, if he used a wool string for his experiment, playing with lightning and so on. And now that I mention that, it occurs to me one of the alchemist's techniques is to prepare a certain group of materials in a bowl, and you put it out in a certain place that's liable to get hit by lightning. And when it gets hit by lightning is when it produces the quickening effect on the material and transforms it into its active state, you might say.
Well,
So
that's
maybe you've put out little lightning rods that are waiting to be charged, and who knows what could happen then.
yeah. I might go poof. The interesting part is the weather's changed dramatically, and I did notice when there's no wind. Too bad, so sad they're not moving. Um, but we had snow yesterday,
Oh,
and
wow.
the snow landed on top of it. And my experience with my nano coating through nature is that the snow seems to really trigger a major nano coating experience for whatever's out there.
Mm-hmm.
And I did coat the outside of the balls with this water mix as well. And so I have not gone out since the snow came, and it's pretty dark outside now. But I'm anticipating there may be a new mm, I knew something waiting for me when I step outside this morning. And I'll take pictures. And
Yes, interesting concept actually. This hanging out in nature, we call it, but you've got the sun interacting, you've got other forces at night and so on that could be blocked by an ordinary house, perhaps, that might interact with them out in
and
nature,
the
so to
rain
speak.
around here, I think it's pretty charged too. So I've had
Mm-hmm.
wind, rain, snow now, and lots of sunshine in between. And it will be interesting to see how it continues.
All right, keep us updated.
Will
Thank
do.
you.
Thank you.
Okay, ladies and gentlemen, what else do we have to present here?
Not a presentation, Rick. This is Denny.
Hi, Denny. How are you doing?
I'm doing good. So I purchased some glass ball ornament balls, clear glass ornament balls for Christmas trees.
Uh-huh.
Did anybody want to see those?
I love to see it. I'm
Well,
sure that
they're
others would
just that
too.
I'm showing you some cheap glass balls is all. Here we go. I'll hit my video. Let me see. Am I on? Yeah, there it is. So this glass ball comes by the dozen, I think, in this Christmas tree thing, and they have a little silver hanger on them,
Mm-hmm.
and
And they are glass, eh? Not plastic.
No, they're glass.
Yeah.
And they're actually very inexpensive. They're so that if you were a crafter, you would paint them and put your own Christmas designs on them.
Mm-hmm.
And so, like down here, somebody is just showing an example of what you do with your own glass balls.
Mm-hmm.
So I just for tonight, I happen to have some little plastic stoppers. I wasn't even planning on doing that, but since I saw them there, I put it in the top, so that comes off, and this little spring-loaded hanger goes into the top of that glass ball. If you do it right, I got one. So that was my point. I bought a bunch of them, and I thought I would go ahead and fill them with GANS, and I got a bunch of cheap little motors that spin at a high RPM. I think they're pretty heavy. I mean, they're.
Ooh, that's pretty.
I mean, they're
That's pushing
pretty
the
thick.
limits.
They're pretty thick.
Huh.
So
Wow.
it's not like they're thin.
Ah! That's a good test. Yeah, amazing.
Well, and you see the edge of the end there is fairly thick, but I don't know if the whole ball is that thick. But there's a lot of them. You can get, they're fairly inexpensive.
Yeah,
And
and how do you think you might hook it up to a motor, and what kind of motor? I mean, there's lots of small motors, like you say. It's always a challenge.
I bought a bunch of them, same amount as I bought for glass. They haven't come yet. I have some other little motors. I even have I have some sewing machine motors if I want.
Yes,
but they're fairly large, and then I could probably even spin it right around the.
What works good is the belt from the sewing machine, or you can use a thinner belt like an O-ring rather than the big belt from the sewing machine, which doesn't like to go around the tight radius so much. But I've experimented with the Singer sewing machine motor, and I ran a globe a little bigger than that. It was a lab flask, actually. And then the 3 ping pong ball reactors around it, all on the same Singer sewing machine motor, which of course you've got a variable speed foot control if you want to as well, which leaves your hands free to experiment with other things while you're varying the RPM. So it's a nice motor to work with, and they're quite quiet, and they don't burn out easily, and so on as well.
Yes, so I have enough of these. I think and you can buy them larger than this.
Mm-hmm.
I think these are 60 millimeter.
And that was off eBay, or where'd you find this?
I think it actually came off of Amazon, or maybe even it came from a private company. All I did was I went and put glass, I think ornament balls. This just says glass ball ornaments.
Mm-hmm.
So I think that's all you'd have to do in Google is just put glass ball ornaments.
It's funny, I was just looking these up in Alibaba a couple of days ago, and of course there's all kinds of manufacturers, and they have them in anywhere from 20, 30, 40, 50, 60, 70, 80 millimeter sizes, I noticed.
So this is 60, so you can get an idea what an 80 might be a little bit. I think there's even, I think I saw one that was 100. Mm-hmm. So, but I was just size. Standardizing them, and I didn't.
That's a nice size. I don't know if I'd want to run the RPMs too high on it. They.
You think it'll break on you?
Well, the thing is, on high RPMs, what happens is where the neck is there, it's the neck that's the critical factor, because you might get a resonance or vibration, harmonic kind of thing happening at certain speeds and so on, and that's when things get shaky, so to speak. And
well, I guess I'll wear my safety glasses and
definitely safety glasses. I prefer.
hazmat suit. I wear my hazmat so I don't get my flak jackets on.
I actually did that kind of thing with my rotating lab flask. I took it up to as much as 10,000 RPM, and it was pretty hairy. But I had a protective polycarbonate cover around the whole thing, so it wouldn't
I
go
got a
sailing off.
face
Yeah.
shield and all that.
It-
So yeah, you can see that
Yeah, that's amazing.
they're not too fragile.
Yeah, but what happens is if it gets scratched, then you get stress cracks and that kind of thing, and there's a lot of force in it. Say at 8,000 RPM and so on, it starts to double and triple the forces because you're working at a what is it, the square of the RPM or something like that. It's not just linear. It actually increases quite a bit as you increase.
Exponentially.
Yes. So, but
So
yeah,
anyhow,
that's a good one though. I really like
I
it.
just showed this so that somebody else could test them, and I could find out how dangerous they would be before I tried it.
Good
So
plan.
yeah, that's what I thought. I got a bunch of other
You
stuff, but
you whetted my appetite. I'll probably dive in.
so
Yeah, that's great.
I'm getting off now. There's
Well,
nothing more that I wanted to show.
That
I
is
wasn't-
it's a really good
I wasn't-
find, especially that the spigot end, the long tube part there that you've stuck in. That's a
Well,
nice
it was
find as well.
this long tube came off of. Let me see here. I think this might be filled with GANS, but I'm not going to use that one. So,
Oh, just a regular plastic tube, like.
well, the plastic tube had was on a bedridden urine bag, so it had this little covering
Oh,
over the
I
end,
see. Mm-hmm.
and so I cut this off of the bag, and I cut the bag open, and it also had another little outlet on the end of the bag so that I could make my GANS in the bag and just open up the outlet and pour the GANS out. And then most of the salt water was in, and then I could put it in. I could put it into another bag. I could bought 20 of these bags. So the value was these hoses are actually paid for the bag. And so and you could even, it's got one of those little holes where you can inject things in it if you want.
Oh, that's a seal, like septiceel.
Yeah.
You can put a needle through it, right?
Yeah. So
wow.
this was hooked onto the bag, this end here, and I just cut that off.
Mm-hmm.
And whatever this was for was beyond me. But because I don't need one of those bags yet. And so, but if I ever do now, I know where to get them.
Yeah.
and so that's why that little plastic thing is. When I first bought these, I thought, well, maybe I would cork them or do something with them because I knew I was going to have to close that in.
Mm-hmm.
And these are just laying around here on my desk. And so when I was going to show them, I thought, well, that would be an easy thing to stick in there so I could hang on to it.
Mm-hmm.
So I bought a bunch of these, and I should just hang them up outside like Libby did. And
maybe.
I might just put sugar water in and let the hummingbirds come.
Great idea.
That's a good idea. What would they like? GANS sugar water, perhaps CO2
Yes.
GANS or CH3 is what they would.
CH3 GANS, and to see if I might have to put. Well, they say you don't have to put the food coloring in. The hummingbirds don't. They're not really.
Mm-hmm.
They're attracted to red color, but the sugar water doesn't have to have food coloring in it. So that's
concept.
it. That's it from Mount Ida.
Okay, thank you very much.
And let me get off of the video and get off of the voice. Goodbye.
Can I share?
Sure. Who do we have here?
This is Guy.
Oh, Guy, I didn't recognize you. Hi. Yes, what do you got there, Guy?
Yeah. I don't know. Sometimes it's pretty weird, how things are pretty in sync, and we all work and efforts and think in the same way. And anyway, I was very much in sync with Denny there,
Uh-huh.
because I had my. Do you guys see my screen there?
Let's see if we can get your video up here. Okay, just a sec. Yeah, we see your video. Just gonna.
I had
Yeah, it looks like it's almost the same thing.
bigger balls, you know. So
Yeah.
sorry, but I found the same thing. It's basically the Christmas balls, and my idea of the whole thing was to actually follow everybody that spoke so far. I got that. I go at the secondhand stores and I hit deals all the times, and I got that thing here for $5.
Yeah.
Has the remote, has everything. This is a very small one. I
And that's
had
got
one that
the double rotating
yeah,
wings on it, right? So you
this
can
one
have
has this one has a dual one that spin in one way and
counter rotating. Yeah, that's it.
which give very cool possibilities, you know. So basically what I did there, this one I didn't do because it's quite a small one, and I don't know if you guys remember, but I got those very little glass containers, and so they fit very well with those shafts there, and it can be all remotely controlled. And anyway, I'm thinking about stuff here for a future project. But I had a helicopter I found for I think it was something like 12 bucks. I was about 4 times the size of this one, and I ended up with a dual shaft and much bigger motors, and that's one of them. But I got the whole controls, batteries, motors, the controls, and which I find pretty cool too. It's let me give you a demonstration here. Um, is the light show.
All right,
Yeah,
free
all
light
these
show.
helicopter come with a little extras in it. Anyway,
Mm-hmm.
my little device here was I use one of those little small one with my GANS in it. This is for Robert, by the way. This used to be copper oxide blue, and for some reason it turned black, and that's what I was telling you last week.
It
A
turned
couple of
black after you put it in there and ran it for a bit, or
no, for a few months it was blue. Everything was fine, and I don't know. One day I realized that what the heck? I had two of them actually put onto a little. I was intent to send that for friends, and um, like little pendants, and they turned this color. So I kind of froze. What happened there? And what was weird was that I made three that day, and the one that I put a little coil around I actually never changed color.
hmm.
And those are the three that I got another one, but I made three that day.
And you didn't rotate them or anything. You just had them as a pendant, like, and they changed color
Yeah,
like that.
I put them on a little string and I just hung them on the wall and they stayed there for a few months, and I don't know what happened. I don't know what I did to it.
Hmm.
Seriously.
And was the one with the coil around it in the same place as those
Yeah,
ones?
this one had a coil from the beginning. You remember that one, Rick? We
Yeah, yeah. And you kept it in the same place as the other ones?
just put it around a string, same thing. You know, it's like
Yeah.
that was the idea. Put a nice little I don't know. Oh, sorry here. Do a little you know
Mm-hmm.
pendant. And the other ones here, I never did the coil on them. So basically, here I'm saying that the one with the coil somehow, for some reason, didn't turn
Hmm.
black,
Interesting.
and the other two, which were hung on a little string, same thing, turned black. They were hung on the wall for some time, and I put, like I don't know, if you guys do that, but I put my best intention into all my GANs I do, and I try to communicate with it, and But here, maybe I left it alone too long, and it fell alone. I don't know what happened. I really, I'm very puzzled too. Why would some turn black like that? Maybe it's a reaction with the epoxy. I did some epoxy thing. Maybe there's something different here because I was experimenting then. I don't remember.
Yeah, I was going to ask you what's inside along with the GANs. What kind of cap or glue or whatever is put on the end to seal it?
The cap, the glue. What was this one? This one was epoxy actually. Was the two A and B epoxy
Yeah.
together, and just put the cap right on top of it. I put that little plastic thing, the little cap that goes inside the
plug, like, yeah?
Yeah, I put the plug and the epoxy right on top of it, so the whole
Okay.
thing. And then I put the metal thing, so the whole thing is still in one thing. I cannot even remove it.
Yeah, so there shouldn't be any contamination there, really.
Yeah.
And it should be sealed to the atmosphere as well, so it's not like the air is getting in.
So what I hear, maybe there's one detail I should say. I'm not really sure if I put a plug or not. Maybe there's
Okay.
detail there. This is I'm here. I'm vague about. I better be vague because I'm not totally sure about that one.
Well, there
Anyway,
might be some interaction with the metal then in that case, yeah.
maybe there is. Maybe there is. Oops, that's my cat. Sorry.
Maybe the cat had something to do with that. That's more
Roger
likely.
wants to say something here, but uh, anyway, this is the little project I had here on the go, trying to get something going. I had a little shaft. I don't know. You guys seen those syringe before? And at the end of the syringe, there's a little plastic thing. So I use a plastic thing fit perfectly for it, and then I put a little sleeve so it holds it very well. And then I got my little motor there, and it fits absolutely perfect with a nice pressure fit. So anyway, here I kind of got my little shaft here going on. And here my idea was maybe I can do sorry. Where's my Here. Can you guys see that?
Oh, yeah, nice.
So it actually fit quite neatly right in there.
Mm-hmm.
Not really sure what to do with that, but basically I got a very nice spinning one. It looks like the Earth actually, and I was thinking maybe producing different type of water GANs in there.
Mm-hmm.
Outer spinning. Maybe you see here I got the very dual nature of this is one of them. Of course, that's not the original idea. The original idea would have to have been the shaft from the helicopter, which has the dual rotating thing.
Mm-hmm. Right.
And this one here, let's say showing it this way would be fixed, and then the inner one would spin.
No, the inner one would spin and might cause the whole of the solution to spin inside as well.
I'm sure, yeah, I'm sure it would create some sort of a vortex or some sort of a donut shape. I don't know, actually. It needs to be experimented to see.
Mm-hmm. Yeah.
The nice is that it's totally crystal clear, and I can get regulated, speed with this.
Mm-hmm.
And of course, this is all in the background. I was working on different projects on the go, but this is my link to the night, guys. I was just saying that we're very close to talking about the same thing here. I don't know where it's going to lead us, but
well, what it reminds me of, or what it sort of leads to, is some of the original reactors of Keshe, basically the ones that had that central pin that was rotating and had different gases inside and so on. And now we're starting to work with this idea of the water of the GANs, the plasma water, and also followed by the plasma gas. So maybe you could fill that bulb with the plasma gas or the plasma water, or plasma water or plasma gas in the smaller one, depending.
Maybe we can recreate a small little globe, having water. There's so many possibilities, but the idea of reproducing a small terrestrial globe is very intriguing to me. Maybe I can get some very heavy plasmatic effect in the center that interacts with my light GANS on the exterior that would be layered and maybe spun like the Earth. Like if you think about
Sure.
the dynamic of the Earth, it's quite similar, and maybe it needs to be some, not necessarily nice, perfect layering, but more like,
With mountains and valleys and stuff.
yeah, that's what I meant by, uh, yeah,
Yeah,
Rick.
that's a cool idea, actually. And
Yeah.
you've got like the Caroline core would be your small globe there in the center, or
Sorry,
maybe.
Caroline, if I put the black one there, I didn't really mean it, but I'm gonna have better one for the real thing.
Mm-hmm. So
That's
yeah.
why. That's
Well,
why.
maybe that black one would light up under the right conditions. That's
Uh,
entirely possible. I saw a video recently of I think it was it's one of the major universities was experimenting with Tesla fluorosis or whatever they call it, and lighting up um, things at a distance and causing nanomaterials to form wires, and the fields of
yeah,
the
yeah, I've
the
seen that. Yeah,
fields of the Tesla globe were causing wires to form from just the nanoparticles.
self-assembly.
Yes, right. Well, perhaps
Huh?
perhaps that kind of a well, what they also did besides the self-assembly is they actually lit up. They had a little globe and little particles were lighting up sparkly, sort of like what we're seeing now. They were all lighting up sparkly inside this container from the Tesla fields that were interacting with the nanoparticles. They were using carbon nanoparticles, but who's to say that the copper nanoparticles that are inside your core couldn't light up in a similar way under certain conditions? So, could have something there.
Absolutely. Anyway, my little bit there. Thanks, guys.
Thank you, Guy. That was great. Perfect. Alrighty. Powell says, "Can I ask a few questions?" Absolutely. Are you there?
Yeah, hi guys. Thank you very much for giving me the opportunity to talk. Actually, I've got a few questions because regarding with last workshop of Mr. Cash when he present, this spherical balls rotating with the GANS water. We've been considering few things. I've done myself the star formation from these reactors, let's say. I don't know if you're really gonna be sorry, able to show the video which one I recorded in a free class. If you are
Um,
in this group on Facebook, because I put my video, oh, sorry,
video of
over there of
which?
my star formation, which one I've made from the last reactors,
Mm-hmm.
and the basic question of people which one actually considering this stuff is when we creating the hydrogen from a reaction between the um, caustic soda and aluminum foil, is that hydrogen is actually in bigger part of the particle of the hydrogen itself, is that the gases.
Is it the
Because
GANS of hydrogen? You mean?
yeah, yeah, Yeah. Because basically, when we take under consideration what Mr. Keshe says on the last teaching, the water is a GANS itself. And now we try to just break that on the pieces, let's say. And okay, in a particle of the water, we've got two hydrogens and one oxygen. And as far as we know from the teachings, the oxygen is one of the biggest magnets, which one actually attracts everything from an environment. So we've been considering that is the hydrogen is the like a memory cell, the thing which one keeps the magnetical fields memory between the water particles. And that's the quite important questions because about the pretty much the Christmas balls, Christmas ornaments, which one are 60 millimeters, diameter. And I put water inside, obviously the GANS water. And I've done the different mixes, obviously with lead inside of it as well. And when I get across with my hands, to very close to that, star formation, I don't feel the resistance, but I feel like, let's say, sword of the wind. It's not because of the rotation, because balls are quite big and they obviously slowing down the spin of the computer radiators. But basically, you can feel the fields. Not like a resistance, but you can feel like, there is something which is not the air only. There is something inside of it. And we've been, considering the hydrogen properties as a gases. And when we are able to create the gases of the hydrogen, or maybe the hydrogen is a gas itself, not taking under considerations different states of the hydrogen. You know what I mean? So
Well,
maybe guys,
Keshe has mentioned the monatomic hydrogen, for example, and
right.
keeps explaining how important it is in the early reactors, at least, to have this monoatomic hydrogen, which makes sense if you want to try to create that plasma. Then it's more of a breakdown process to have to break down the H2 to H plus H, the monatomic hydrogen. So it's already in a state that's ready for plasma, let's say, in the monatomic form compared to the H2 form. So it would be preferable in a plasmatic situation to have the monoatomic, which might be the same as GANs of hydrogen. Maybe that's the
Yeah,
same thing.
that's what we be actually thinking about, because I remember one of the teachings Mr. Keshe was presenting the Mendeleev table when he shows that actually everything is other way around. I mean, when we take under consideration the atomic mass, everything is okay. So that means we describe the matter state. But when we take the plasmatic state, actually everything works other way around. So that means when we calculated the hydrogen atomic mass, we have to take off that mass a minimum 50% of it. So that means, in my understanding, that the hydrogen is a GANS in a state of matter. That's pretty much the same. It's like more half and half, if you know what I mean. So basically, when we evaporate the hydrogen, actually we're not getting only monoatomic the hydrogen, but we're getting straight away the gases of the hydrogen. Because our biggest consideration was it's very hard to get, the glass containers, which one are very small diameter, which one the computer motors can run with appropriate speed, if you know what I mean.
Yeah.
I've got 60 millimeters diameter balls, and they drastically slowing down the radiator. So obviously the
Yeah.
spin is not fast.
You can get more heavy duty ones as well. I've got got a lot of fans stashed away. Everything from tiny little ones through to the larger ones. And the little ones will just cut out or burn up, or the bearings will go very quickly if you put a large sphere on them. The bigger ones are some of them have magnetic bearings that can last 10 times longer than the ball bearing types and so on. So I've got ones that have light shows that they do, and they're variable speed switch on them, so you can actually vary the speed right on the fan itself, and this kind of thing.
Yeah, so let's say we're gonna work on that, because probably I'm gonna have to ask that question as well, Mr. Keshe, when we're gonna start the class sessions. What actually the hydrogen in the state of matter really is, because that's what we actually looking for. We've been looking previously the gases of the water, and suddenly last Thursday, Mr. Keshe gave us a beautiful knowledge saying that the water is gas. Is in a gaseous state itself, so we don't have to do anything with it. So going, through that logical thinking, everything what the water is creating from is actually the gases itself. So that means we've got the gases of oxygen, hydrogen in the same time, and that will help us to develop the further projects. But the other thing is taking under consideration Mr. Emoto, experience with the water, and he's developing knowledge regarding to the water properties. We just start considering when the water actually lose the memory. So that means when the water lose the magnetic fields, which one are contained between the particles of water. So that means we know that when we froze the water, we are losing all the plasmatic field strength, which one is contained between the particles of the water. So what's going to happen when we're going to start boiling the water? Is the process occurring in the same way?
Mm-hmm.
You know what I mean? Because I was thinking, okay, if we have a problems to get the spheres, the crystal spheres or the glass spheres in a very little shape, how we can decrease the weight to increase the spin of the rotors? You know what I mean? So this way would be to evaporate the water. So basically boil the water, kept the steam, and trap the steam inside the balls, and then actually we don't have to use the water, and we've got the same properties as the water, gas water, you know what I mean?
It would be plasma vapor, basically, is what you're talking about.
With the same properties as the water.
Right, yeah. And Keshe has mentioned that or hinted at that in the last workshop, but he also mentions or guides that the container would have to be special under certain conditions so that it be able to sustain that plasmatic environment.
So that means we will have to heat up the container to keep the evaporation all the time.
I'm thinking I'm thinking room temperature, but under a vacuum. It'll cause it to be at the point of
pressure,
boiling.
yeah.
So you vacuum it to the point that just starts to boil, and that'll maintain the vapor without having to boil it. Maybe you could heat it a little bit, would be enough to do that. And with the right nano-coated container, so it would keep the plasma contained rather than disperse it or absorb it, then perhaps that would be a way to go.
I'd like to interject. I'd like to interject a thought here. This is Denny. When you go back to the Coke bottle experiment, that one of the very first things that Mr. Keshe taught, and he always tries to mention that to us from time to time, we don't quite look at maybe there is a GANS vapor that's being created right there.
Mm-hmm.
Because of that. So when we start to look at the nature of GANS, it can be a solid, it can be a liquid, it can be a gas. And so perhaps as we take another look at that experiment of Mr. Keshe's, we might find more going on there than meets the eye.
Possibly, yeah. That's why I raise these questions, because there is something definitely going on in the background, which one we are focused on the matter state, but this matter state not necessarily have to be relevant to whole thing, if you know what I mean. So maybe we should, because what I'm trying to keep the whole project in a very simple way. So if we're gonna start overcomplicated things, then actually, we can land up with nothing. And basically, a lot of people will start thinking, okay, I'm not, capable to do it in my garage, let's say, or in my kitchen, wherever.
Mm-hmm.
You know what I mean? And I think, the idea of Mr. Keshe is just to show us the ways where we can achieve reasonable effects in a very simple way. So that's why I will go to my next question, because we make some searches on the crystals, which one are produced across the world. And there is a different crystals, because as Mr. Keshe mentioned on last teaching, the crystal balls or spheres are the best containers to achieve the best results.
Yes.
So basically, probably that coming out from different, let's say, structure of the crystals. And we start considering why. And many times, Mr. Keshe, between the words, he mentioned that the lead is a very good absorber of plasmatic fields.
That the crystal glass is?
Yes. So we start, searching about, we've done so searches about the crystals, and basically the crystals produced across the Europe, they contain from 10 up to 30% of lead.
Mm-hmm.
Yes. So obviously, taking under consideration the manufacturing process of the crystals, so this lead, which one is contained in a crystal, should be in a GANS state already.
Say that last part again. That the lead in the crystal, is that what you're talking about? Should be in the GANS state already?
Yes. Yes. Taking under consideration the manufacturing process.
Okay, well, that's possible. What I ran into was the idea that the crystal glass passes, I believe it said passes ultraviolet light much better than the regular glass. Let me just get, I want to get the Wikipedia up on the... It's interesting. Hi.
Hi, it's Robert. How are you?
Hi, Robert. How are you doing? Good.
Good. You guys got a very interesting conversation going. I wanted to jump in.
Okay, let me just throw up this on the screen here while we're talking. I just wanted to share this, and then you can go ahead. It's the Wikipedia on Bohemian glass, and they have a thing on crystal versus glass. And the word crystal means in most of the Western world the presence of lead, but it also is different in different countries, and it can mean anywhere from 2% up to 40% lead, and so on and so forth. In fact, in the USA, it's the opposite. Glass is defined as crystal if it contains only 1% lead. So it's interesting, this lead thing.
Yeah, that's what we actually start paying attention to it. And I know Sander typed something in the chat. I'm on the mobile, so I'm not very capable to track the chat. But let me have a look on it. Yes, Sander, that's why we start focusing on the crystal more rather than on the glass, because we are heading not to matter state and not to different states of the different, ganses, because the ganses is still a, matter state in sort of way. But we're trying to get to the plasmatic fields, which one are the highest speed. So we're trying to get from a matter speed to the transmission speed. And then even if our understanding will be good enough, then probably we're going to be capable to get the primary matter speed of plasmatic fields. So that means the crystal probably contains all three in quite easy, accessible way form of the fields. That's how we understand it. And this is a question. This is not a state. You know, I mean, I'm just looking for the answer.
Well, it's interesting in the Wikipedia here. It says lead increases the weight of the glass, so we've got more, gravitational effect there. Causes the glass to diffract light. Glass can contain up to 40% lead if maximum hardness is desired. On the other hand, crystal can contain less than 24% lead if it has a high proportion of barium oxide, which ensures high quality light diffraction. Now, I'm wondering if this light diffraction is an important idea here. I mean, we're dealing with plasma, light, diffraction may be one of the main sort of factors. And if you look at diamonds, for example, diamonds diffract light. That's what they're so good at doing, and that's why they're so expensive. Perhaps we need this crystal glass in order to obtain this diffraction gradient. And I would propose that the high proportion of barium oxide might be important too. Barium in itself could be an important element to add into the mix. Go ahead.
Oh, yeah, Rick. I've been looking at these crystal shapes in the star formations, and the reactor I made here, when I put the coils in, they all aim in, and the crystal shape, it's a crystal inside a crystal, the star formation, it focuses absolutely, every corner focuses directly into the king's chamber of the first pyramid. It focuses the fields. They spread out, so they go in both directions, but the shape of a crystal focuses into a central point. This whole reactor that I built, every one of those corners, every one of the coils is aimed. I got the gravitational has to go in, and because of the angles of the corners, the way I had to set the coils, they're all aimed directly into the center, all 12 corners, right into the center. It's the nature of the crystal.
Okay.
You know what I mean?
Thank you, Mario. Now, Robert had something I think he wanted to say there. I'd like to get back to that first, and then maybe you can show a picture of your setup, Mario, or are you able to do that?
Yeah, sure, I can show you. I got a couple of things going here, so I'll just show you the video, but okay. Sure, let Robert do it.
Yeah, just Robert had something he wanted to bring up there about this train of thought, so to speak.
So may I ask Rick my last question?
Oh, okay. I'll finish with Paul first.
If we're gonna obtain the answers for some questions, which one I raised up, just a few seconds ago, the last thought here is if we have the free stacker, the Magra free stacker, if we're gonna put the crystal ball on a top layer, we actually can obtain the free star formation, so the star formation, just using a stacker and a crystal ball. Because we're not looking on the shapes, we're looking on the fields interaction between. So that's the question. You know what I mean?
Well, generally the stacker has the horizontal coils, 2 horizontal coils, you mean, right?
Yes. The standard, Magraph.
Right. Yeah. And there's question whether that can be used as a star or spaceship configuration or not because of the flat coils, rather than having one coil vertical and one horizontal, which creates different fields. There's the stacker creates a vortex type field, whereas the other coils that are counter to each other creates a spherical field. And in the spaceship configuration, you want more of a spherical or globe around, a sphere around you, a protective envelope, you might say, as opposed to a vertical, more of a vertical vortex with the stacker units, is the way I understand it. Is that...
So what about if we, because there was, I think there was a few months ago, a beautiful project when I think the Richard or someone like that, he posted on a Facebook when there was a ball actually placed in the middle between the layers. So if we're gonna use, because I'm not looking on a matter state, so I'm not looking how the device is built. I'm more looking for the interaction of the fields between. So in that terms, if we're gonna use appropriate state of the GANS, that's why I raised my questions earlier on about the hydrogen and the crystal. Because when we're gonna have a strong plasmatic fields inside of it, they're gonna be probably strong enough to suck everything in, and then when we're gonna use appropriate mix of the GANs on the different layers, making them more magnetical going from the down to the top, we should achieve the same result. That's just my understanding. I don't know. I just want to, correct my understanding. And guys, you know quite a lot as well, so probably you're gonna give me, some tips or advices or maybe correction in the thinking.
Anybody have something... Anybody have something they'd like to comment about that? I think
I wanted to offer a different perspective on what water is. So far we've been looking at nano states and GANS states, and both of those seem to be related to oxide nature of the elements. So in my opinion, water is a hydrogen GANS or nano state of hydrogen, being an oxide, sort of a hydrogen oxide, H2O. And you could also have the other oxide state, maybe like the brown gas, HOH, and the easy water being another sort of a GANS or nano state of hydrogen. And in the structured or easy state, it is a liquid crystal. So if we're looking for a crystalline structure to play with, I think easy water could be a good candidate. Yeah, well, easy water would be the H2O3 state of water, where it separates, it has a charge separation. The portion of the water in the container, in a hydrophilic container, gets, I believe, negatively charged, and the portion outside of that exclusion zone, as Dr. Pollack calls it, becomes positively charged. So it becomes like a battery. So you have a water battery. And he was saying that it's in a crystalline, liquid crystalline form. and it has different diffraction properties compared to regular H2O. It has the property where in a narrow channels it flows by itself without any external propulsion mechanism. It just flows within a narrow tubes, so it has a pumping action. So I think that could be thought of as a GANS state of hydrogen, one of the states, and water, regular H2O being another oxide state of hydrogen. It it grows. That zone can grow if it's illuminated by infrared energy and ultraviolet energy. So it sort of organizes itself. It increases its negative entropy by absorbing infrared and ultraviolet spectrum. Also, the glaciers are these structured waters. Any ice, I think any ice can be thought of as a frozen structured water, because as water goes towards freezing, it goes through this fourth state of water before it freezes. So it starts structuring itself, and then finally, when it gets to the right temperature, it freezes. So it sort of, I guess you could say that the memory is frozen at that state, and when they were saying the best source of structured water, easy water, would be glacial melting glacial ice. So you could maybe create a spherical ice shape, spin that, or spin just regular water if it's a GANS state of hydrogen. And water being, I guess, one of maybe two compounds that when it's frozen, rather than contracting, it expands. That's another unique property of water, which makes it special. Ice cup.
Sorry, my microphone wasn't on in live stream there. I was just saying, when you think about, I was talking about these frozen cups that you can make, an actual frozen cup with these plastic things you put in the freezer with water, and thinking about rotating them with GANS or GANS water inside and so on, and possibly the idea of actually creating a gradient by rotating these glasses made out of water, out of GANS water, maybe easy water.
Well, easy water would already have a gradient in there, electrical gradient by the charge separation. And I guess as that freezes, it should maintain internally that electrical charge gradient.
Yeah, it's a fairly thin, it's about maybe, it's less than a quarter of an inch, maybe 3/16 of an inch wall or something on this. So perhaps the easy water would have a high percentage inside of that cup formation to start
Yeah,
with.
also if you could find a hydrophilic material, and I think copper oxide, nano-coated copper, I believe would be hydrophilic.
Mm-hmm.
I was looking at some plastics to see if I can find something that's hydrophilic. I haven't done a lot of research, but I haven't found anything that's.
Well, you can change plastics with a plasma coating from hydrophobic to hydrophilic and back again and so on.
Yeah, yeah. So that's just another different perspective on water as being an oxide of hydrogen.
Yes, that's an interesting idea. And the other interesting part, like Sandor mentions, important point to remark about lead glass is its property to be a barrier for ionizing radiation.
Yes, and what makes it interesting that the energies collected within that crystal glass tend to remain inside because of its lead content and because it is a barrier. It doesn't let the ionizing radiation go out. Once Mr. Keshe warned in the private teachings about those who are wearing such as Swarovski crystals. Swarovski crystal is just a lead crystal, lead glass, cut in a specific way. You know, that beautiful crystal shape is done by cut, not by natural formation, but the material contains a lot of lead, and those who are wearing it are prone to get certain types of cancer.
Mm. Well,
meanwhile, if you use it for some kind of reactors, etc., that can be used to hold within certain type of ionizing radiation. So it can be used for radiation shielding, actually.
Mm-hmm.
You know, lead is used as a radiation shielding, and where you need transparency, you need a window, you use a heavy lead glass. And it doesn't have to have to be percentage, something about 20-30% lead is quite fine.
Mm-hmm. Yeah, I was surprised to hear such a large percent of lead. Of course, it's lead oxide, but still, it's lead.
Yeah. That's interesting in glass, that there are some materials which became transparent due to the process at high temperature. Otherwise, all the components of glass are not transparent before you make it in glass.
Yeah, it's basically sand.
It's sand, calcium carbonate, calcinate soda, and some other components. Also, there are such as borosilicate glasses, other composition. Those are the heat-resistant glasses.
Silicon
basically
dioxide.
Made of sand and soda.
Yeah.
And the reason why glass tends to become expensive, it's because the soda mines and reserves are just get to be within some monopolies. you know, I'm from Romania, and there we had a huge production of soda. And after the political changes, it was privatized by a tiny company. And that sold its shares, sold the company to a branch of Tata, an Indian company who is one of the largest exporters of soda. And they kept it working until they had obligation by law. And after 2 years, when that term passed, they just fired all the staff, all the workers, and they closed it just to keep the price, the supply small and to keep the prices high. Interesting things, isn't it?
Yeah, the same is true with diamonds. Diamonds have really no value, but because they have monopolized it, they can control the price of it. And
yes, diamonds are very useful if you need to make some special drill bits, for instance. Otherwise, they are pretty useless pieces of beauty, not so needed for daily life like water. And yet, diamonds are expensive than water because there is a limited supply. Always the ratio between demand and supply will determine the price.
yeah, and marketing, good marketing.
Yes, and you have to know such a soda was the cheapest detergent which was used by our grandmothers. So they used the housemaid soap and they used soda for the white cloths for the sheet, bed sheet, for instance. They used to boil it, so to wash at high temperature with soda, they became white and clean, no problem. But because of the glass industry, which is always increasing due to automotive and architectural industries, building houses and making cars which need windows, screens. So that's why there is a huge demand, and it's a big business when you can hold a special component of the glass high. So the big glass companies have to pay a high price for that common caustic, not caustic, the calcinate soda. It's a
So
sodium carbonate.
sorry for interrupt you, Sander, but because that what you've mentioned just earlier on, if we accumulate, because we're trying to sort it out, you know, the single reactor, we're not talking right now about the star formation. We're just talking about the single reactor, which one components are the crystal ball and, you know, some spinning thing, which one makes that, you know, spinning. So actually we accumulate there. But going back to the rule, we have to give away what we've absorbed, actually, to keep a balance. So that means that single reactor, because taking under consideration our human body, which one is totally plasmatic, we can actually use that, you know, reactor for heating ourselves and basically creating all the sources of the energy because of big absorption of lead of different plasmatic fields which are going to be necessary to keep our human life structure going on.
Do you need lead for that? Look at human life structure. How much lead do we have? Sorry. If you mean about human life structure, why do you need lead there? How much lead do you have in living bodies?
No. I'm not talking about this. I'm talking more about, you know, the radiation which one can possibly occur. And then obviously this single reactor help us to create a shield, which one, you know, actually protect us from this. So that means when we create that shield, we absorb a lot of energy. And as far as current knowledge tell us, a lot of, you know, radiation, let's say waves going through the atmospheric, you know, structure from a universe. So basically through that little reactor, we can actually, or possibly, we can create all sources which one are in the terms of the plasmatic fields capable to keep us fat, health, and warm.
Yes, of course. Lead doesn't have to do too much with that. So lead is good when you need to protect yourself of external radiation, like a nuclear power plant or
Yeah,
something.
that's
But
what I
it's
thought.
not really needed when you are working with the plasma technology, because you can if you learn to manipulate to handle and to control these magnetic fields, you can create whatever shield you need for whatever strength of radiation. And it's better to have something flexible which you can control it rather than to use a matter state one.
For health purposes, I think human body needs mainly the infrared and ultraviolet spectrum, being
So
almost.
what you are talking, ultraviolet, etc. So there's already about light.
Yeah. Being mostly water, our bodies absorb infrared and ultraviolet spectrums. And if
Yeah, so that's what, so why we have shielding on our skin. You see, if you live more to a more sunny place, you have a darker skin. If you are somewhere in Scandinavia, you have a whiter skin. It's because just a natural protective shielding against ultraviolet.
well, you
Some quantity you need a certain type of ultraviolet, but not the extreme ultraviolet. You need ultraviolet A and not B and C, which are quite harmful.
well, no, actually, you need UVB, which is the one that produces vitamin D in your body.
Yeah, it's a catalyzer for vitamin D.
Yeah, and you need the infrared, far infrared and infrared frequency, because in your body, water exists in the H2O3 form. And in order to increase the structured water in your body, you need the infrared energy and the ultraviolet. So I think our bodies are like water batteries, and we need to charge it with infrared and ultraviolet to keep our health at a high state. It's when,
Sorry to interrupt here, but how about tritium and deuterium?
what about them?
Well, I think in heaviest elements, we're gonna actually be able to achieve in our reactors then better, because we're gonna take under consideration the Mendeleev the structure of the whole principles, entities existing, which one we are able to describe. In heavier atomic mass, then more gravitational fields those entities actually possess from a nature state of being. You know what I mean? So the lead is actually the easiest one to and the most common one for all of us to obtain and to use into the reactors, because I remember, like Mr. Keshe mentioned one time, that we can create a lot of things, a lot of matter from buying the fire alerts, because there is Americanum, or what kind of heavy elements, radioactive elements that was inside of it.
That's
I don't
right.
want
Yeah.
to. Yeah. So basically, I think we're not supposed to consider that in the terms of matter state, but more in a plasmatic absorption of other fields, plasmatic fields from environment. And because they are very heavy, so that means they're very gravitational, so they're capable to absorb more. But then we have to go back to the rule: if you absorbing, you have to push it out somehow. So that's my question: how are we gonna establish all these rules in our little reactor to fulfill all requirements created by our body and environment? That's just my consideration. You know what I mean, guys? You know what I mean? Sorry for interrupting you, but I'm just trying to logically sorted out few things which are going around me, like a human being, in times, let's say, of the earthquakes or whatever, when we've got so many reactors, you know, nuclear reactors across the world, and what's going to happen with this radiation? What this? Okay, we're going to accumulate the energy, but what are we going to do with this energy? And how we can?
Sorry. By the way. Sorry for a short interruption, but the subject gets very much spread into so many directions that it will be hard to keep on a single point. I remember here you told about the need of heating the body, and you told about infrared radiation. So actually the heat is produced by the friction of the fields. So you can produce heating without having an external infrared radiation. When Mr. Keshe talked about the Oasis project and about heating systems based on plasma, he meant you are not going to heat all your walls or your furniture in the house. It's not an economical way where you need thousands of kilowatts power. But he talked about a system where you feel the heat wherever you are. So you have some reactors around you, and wherever you are and you move around, you have the heat exactly in your place. How it's produced? It's produced by the interaction, by the friction between the fields created by your own body, your own internal, natural, biological magrevs, and the magrev which you have outside. So now it happened, a thing which I reported in Knowledge Seekers workshop, but was mainly about peace, so that's why it was nearly unnoticed. It was Knowledge Seekers from Hungary, Mr. Zoltán Szabó, who has made several magrev units. And he started to make a magrev unit with the coils in a reverse direction, because it was some little confusion at the beginning about what's the right direction of making the coils. And an interesting thing happened there. So he had in his room, if you can see this one, light is not the best at this time of the day. So he had here his desk. He had the door here, the door here, door here are the windows, and here he had a magrev unit, and he had a second magrev unit. Now what happened? After he had two magrev units and everything was fine, he thought to move one magrev unit away, and he put in function a magrev unit, which was the first which he made, which was not in the right direction, but coiled in the opposite direction. I remember we had a workshop where we discussed about the direction. Mr. Keshe corrected that it's a different one and said no problem. Those who had the magrev coils in the wrong direction, don't throw them away, because later he may show us a way how to use it for heating. Now what happened with this gentleman here? He put here a magrev which was in a wrong direction. It means it was gravitational and not magnetical. And the other was mainly magnetical. And since that moment, something interesting happened. Whenever his wife was walking here through, while he was here, she said it's so hot in this room. Actually, it was only 18 centigrades, but she felt really hot. And that was in the area between these two magrevs. So it was here created something, a specific strength of magrev fields by accident, which was tuned exactly to that magrevs of the body, and created the friction of the fields between the magrevs of the body and this field. So it was achieved quite accidentally, this heating. Not heating the entire room because temperature was unchanged, but whoever walked here felt heat.
Yeah,
so this is a very empirical and experimental stage, but we can work upon that one to create such kind of fields in a specific way. which get interacted with the fields of the body. So you can have the heat wherever you move. But you understand, if you have a single maglev unit, so that's spread all around, in order to control an area in which you want to be, for instance, a room, you need several ones to keep inside. Maybe 2 was the minimum, but maybe with 3 or 4, you can achieve a better shell inside where you want a protected environment. Having the heat you need, having the energy you need to feed your body. Some like they will be the spaceships, where we have a place like in a bubble or like in an eggshell, surrounded by specific maglev fields, which to create your shielding, your protection, to give the feeding for your body, and to give you the gravitation you need, and to give you the heat you need. So don't forget, our purpose is ultimately to enable man to be able to travel in the deep space. So we should focus on that direction. But for that, we have to understand about plasma. Actually, we have to get those books, to read them, to understand the basics, and then by playing with our experiments, I see playing is the best way to learn, to understand what we do and what we observe according to the theory. So no practice without theory, and no theory without practice would be too useful. We have to put these two together.
So how we can, that's beautiful example, which one you just presented, because that's basically shows us that when the magnetic fields rub against each other, they basically create the heat, but this is not a physical heat, it's the absorption of the plasmatic of fields, which we can attract to us as a human body.
It's the physical heat which you have here on the planet. Think about that, you have the sun, you have the earth, each one it has its magnetic or gravitational field. And that's why how atmosphere is created, and that's how earth is heated up. So if you have here the earth, if you have here the sun, you have the fields of one, you have the fields of the other. And actually in earth you have to know that you have it's a double core thing. It has the internal core, which Mr. Keshe named the Caroline core, and between that and between the sun there is always an interaction of magnets, and this interaction determines whatever happens here at a certain distance. So there is creation of matters. Where do you think we have oxygen or nitrogen? At certain distances relative to the core of the Earth and Sun, you have the magnetic strength of nitrogen 15, which you have had some quantity in nature. Then you have that for nitrogen 14. Actually, there is isotopes. You cannot get many elements in a pure state because you get a spectrum of them. For instance, in case of copper, we say copper is 64. Actually, copper 64, it does not exist in nature. You have copper 63, about 70%, and you have copper 65, about 30% in nature. And what you find in the periodic table of elements is just an arithmetic average, which is not existing as itself.
So thank you, Sandor, very much.
Such a spectrum of elements is created at a certain distance, certain position between the sun and earth. So that's why we have atmosphere. So here you have strength of oxygen, strength of nitrogen, different kinds of nitrogen. And because of the heat, the interaction of the fields, that's why you have a heating of the atmosphere, of the Earth's crust. So here you have a heating. It's not because you have a hot magma, the old theory. It's a fallacy that you have something hot which is heating up. It's actually the interaction between the fields which creates that heat.
Thank you very much, Sandor. So you basically answered my question, where we can obtain all of this from one single reactor. Thank you very much.
Okay, so you have not just one reactor, you have to consider all the components, all the conditions. You have the gravitational field of the Earth, it's a huge reactor, is it so? whenever you make an experiment with reactor, you have here the strongest neighbor, it's the Earth itself. And there is an interaction in between. And you have the fields of the sun, and you have the other fields too. So a big mistake is when in the school you are taught about the structure and functioning of a single atom. Actually, something like that doesn't exist. So by studying a single nucleus with a single electron around, you can't explain why the electron is spinning around without considering the other fields around. There are other atoms around. All is in a system. We talk about vacuum, and I don't know whether somebody can show a single place, a single cubic centimeter in this universe where there should be nothingness. Because everywhere you have fields. You know about neutrinos, which penetrate the entire cosmos, the entire universe, and goes through the Earth. It's possible to be detected. It's very sophisticated equipment, but it doesn't make too much effect, so we don't even feel that such a neutrinos goes through. So this is to make a connection to the traditional classical academical science. But think about the fields. Can you shield the gravitational fields anywhere? In any position in space, you have something. You never have a perfect vacuum. So if vacuum by definition means something with nothing inside. So always consider all the conditions which are inside. You do experiments with CO2 kits or with generators, these magrels, and you see difference when you are at the ground level or when you are on the 30 meters high building. Because you have different strength of the magnetic or gravitational fields of the Earth, which are influencing all. You see different results when you do now coating, if you keep your container in the middle of the room or you keep it in a corner or near to the walls. Even though we don't see all the conditions, but they are existing, such a magnetic or gravitational conditions everywhere. And that's the tricky part to understand what is where, in spite of we cannot see and perceive all. Yes, somebody told about maybe in such a glass globe, some part of the GANS may be a vapor. So, but how can it be vapor when it is a nano-solid? So solid means so solid. Does not matter if they are solid particles floating in water or they are solid particles which are dried off and finally they go back to the nano state. You have to understand the difference between matter state, nano state, and GANS state. And there is a crystalline form, which is the odors. It's another state of the matter. Scientists don't like too much to study and discuss about odors because although we can feel them very, very strongly, but we have no scientific instruments to measure an odor. So that's why academic science avoids that, because everything has to be mathematized. And how to make the mathematics of the odors when you have no ways to measure it, but you can feel it everywhere. An odor, for instance, it's a single molecule which fills the entire room. So it has a very interesting shape. It's not a tiny thing, like a nano shape. It occupies the space, the entire space in which it is. If you put a single molecule of odor within a room, you can feel that odor in any corner, in any place of the room. And that's a funny thing. So it's a different state of the matter, absolutely. Same with the GANS state, same with the nano state, and they having different structure and different behavior, like the usual matter state, which we are learning that matter state is either solid, liquid, or gas form.
Sandor, why are you saying there is no instruments to measure odor?
Do you know any?
Oh yeah, there's a lot of instruments that measure, what is odor? It's just, chemical compounds in the air. You can
it's
measure.
Smell.
Yeah, what is the smell?
I know the best detector are still the dogs, and not the digital noses, which they are trying to make, but still it's art in infancy. You know, when they are detecting explosives or drugs at airports, at the security check, they use dogs or pigs.
Yeah, but there are ammonia sensors. There are, you know, other.
No, that's a gas detector. Ammonia is not an odor. Ammonia, it's a gas. Of course, gases have odor.
Well, what's your definition of an odor?
Something which has a beautiful smell, or it stinks. As I said, a single molecule of odor, state matter, can be felt in any position in the room.
Well, it has to reach your nose, your detector, to be detected. How can it be sensed?
So this is the strange thing. This is the strange thing. Even in the 70s, I read as a child that there are some perfumes which a few molecules, because you cannot just produce a single molecule, but they measure just a few molecules, can fill an entire hall, an entire huge room. So if you have here a room with its walls, and you have somewhere here that one single molecule of perfume, let's say, or something that stinks, or a perfume, in that case, your nose can be here, or your nose can be here. It still can feel that smell. Doesn't matter in which room. But you have a limited quantity. You don't have many molecules to spread around like a gas. It's only one single tiny molecule, but the molecule itself, it's in a plasmatic state that it feels everything until the next matter barrier. So it's a molecule which is not confined in a small place. It just fills the entire room, and it's a single molecule. What's the strange thing about that?
I haven't seen any studies like that. If you have anything, if you can send a link, I'd like to read up on that.
Please use Google. I'm not your secretary to Google for your links which you need. I was a kid, it was no Google, it was no search engine, it was the ISBN code, the decimal code. We went to the library, and there was such a racks full of cartons, and we had a catalog to know for which subject it's classified where, and we were seeking. Please learn to find your sources and learn how to make your studies. Don't expect others to supply to spoon feed everything, please.
I'll make it easy for you, Sandor.
Finding the information you need. It helps the intelligent to use better your mind. It's a small exercise. Don't be afraid that if it's not given on a plate, you don't find it. You will find it easier, even without the internet.
You got to remember the shark that can smell a drop of blood in the water 1,500 miles away.
Yes, of course. Oh, welcome, Brett. I'm very happy to hear you.
Well, I've been listening the whole time. I'm just not feeling well, so.
Okay. Yeah. You're welcome. So my purpose is just to put some things on the normal route, not to get lost in so many sideways. Just to keep focus on plasma theory and on plasma technology. So what I recommend, I say, read the books, understand the basics, especially book 1 for the beginning, and make the correlation between what you find in your experiments and what's the theory behind. It's no other way how to understand plasma. And thank you, Brett, for your addition. So, you know, in Army, we have learned for our own safety that if you light a cigarette, the enemy can smell that cigarette from 5 miles. And it doesn't produce so much quantity of smoke to go everywhere, but the odor goes to a huge distance.
There is a famous shootout in the West where the bad guy was supposedly holed up in this cabin or whatever, and the I don't know if it's RCMP or some sort of troopers that came in to get him. They kept getting shot, and they couldn't figure out why. And it's because they were smoking when they were trying to stake him out, and he was sneaking around. He knew exactly where they were from smelling them, because he was a bush person who had highly sensitive smell, and he was basically picking them off from their cigarette smoking. So it's interesting how we can become super tuned to the smells in the environment. I know
it's actually a matter of training. Look at the bushmans. Those who can survive the Kalahari Desert, they found the tracks by smelling. They smell where is the animal which will become their dinner.
Yeah. And another example is the fishermen in Newfoundland, where it gets really foggy, so foggy you can't literally see your hand in front of your face. And if you're out fishing and this happens, how do you get back to your bay where you started out from? Well, the way they do it is by smell. They can smell their native bay, the bay they came from, and are able to go by smell to get back to it in the ocean when it's so foggy that they can't see. So I thought that was pretty amazing, and it's true. You can even crudely, if you smell different bays, and I know on the west coast where I live, there's several different bays that have a very distinct, so to speak, distinct stink to them. They have a certain smell that's particular to the different rotting vegetation and other things that are in that particular bay.
Yeah. And actually, when you smell your food, you keep yourselves very safe to not eat something which is rotten, accidental.
And it's interesting that the sense of smell is the most direct to our brain of all our senses. It's the one we get the first information on. So when you enter a room, for example, the first thing you get for information in that instant that you open the door is smell. And there's certain shamans in that's how they operate. They go into a room and they smell the space. They can smell the presence of entities and the whole thing that's going on in that space just from its smell.
That's true. And now think about when you have your plasma reactor working on, even though you have your static reactors, which are your CO2 kits, when you enter in the room, did you ever notice how the smell of the place is? Because it is going to be changed. And from that smell, you can have an idea about something changed in the conditions inside.
That's a really good point, I think.
But very hard when people got lost their sharpness of the sense of smell because using everywhere perfume tissues, perfume toilet papers, deodorizers, all kind of synthetic perfumes which are not natural ones.
Yeah, we're overwhelmed.
It's like being in a noisy place that you cannot hear the tiny the sounds because the sense is suppressed with too strong stimuli.
That's right. Yeah.
I go to travel with a tram, and I am in the front of the wagon, and in the back of the wagon, somebody climbs up and gets up and has in his mouth an orbit chewing gum. I just cannot bear the smell of that aspartame.
Yeah.
Not of the mint, the aspartame. So I had to get down and to move to the next wagon at the next station.
Yeah.
People don't realize what a stinky thing they put in their mouth.
Yeah, I'm super sensitive to smells, and I can tell probably 100 different car exhaust smells and truck exhaust smells just from smelling them from, unfortunately, up to a kilometer away at times. So it's really quite aggravating to try to go through life and being super sensitive to smells and actually reacting to them in that case as well.
Yeah, so by a little training that can be achieved. And also, they have other senses. We have sense for the magnetic fields.
Mm-hmm. Yes.
But because we didn't use, because we have such a life that we have everything at the push of the button, our senses got diminished very much. But with certain training, you can get that feeling about the magnetic fields.
Almost every animal has that and act on it, and humans are one of the only animals that are too insensitive to it.
Yeah, just put in a box some cockroaches or some, doesn't matter which kind of insects, between the poles of a strong magnet, and you will see them how they find very quickly their orientation north-south.
Good point.
We have among knowledge seekers those who feel very well these fields. Mm-hmm. And just by reaching with their hand, moving their hand in their space, they can sight the intensity of the fields in a specific place in comparison with the other place. We have such a people in our PID, Product Innovation Department.
Yeah, Ali had us, when we were visiting Ali's installation in Vancouver, he had us do a little exercise of doing a penguin walk toward the maggrav, and so your body was going sideways back and forth, and make it sort of easier to sense the feels that way if you were sensitive to them. So rather than going directly toward it, but sort of at a sideways sort of waddle, and it makes sense that if you're sensitive, then you would be picking up the fields easier that way. Okay, we got to start wrapping things up here. Mario, did you have something you wanted to show there again, getting back to you? Or does anyone else have something they would like to show as well? Or ask, tell, etc.
Hi everyone, it's Alper from California.
Okay.
I just like to tell you my experience. It's quite funny. It's about the smell. That's just why I try to. This smell subject came up, I think, months and months ago, and I remember people experiencing different smells in the room. So since I heard that, I was concentrating on the smell, like how it would be different. And some days, this happened a couple of months ago, and some days, really beautiful smell coming. It's just like, oh, flowers. Oh my goodness, I can't believe it. It's a literal smell that I feel, and I can't believe myself that I'm smelling that went on months and months and months. And each time, those special days, I felt like, my goodness, this is angels all everywhere. It's just, I can't believe it.
I've had a similar thing, actually.
And in the end, I realized something. So those days were the days my wife was using the dryer and the washing machine. The outlet pipes were coming out, all smelling amazing. And windows were open, doors were open. And those days I thought, I was like, I can't believe it. This is just amazing, beautiful smell. It is beautiful. I mean, yeah, it smells just amazing. But the mind wants to think really is just, this is magical. And immediately after that I have started noticing this smell. The first smell subject was talked about months ago. That's really interesting. Like that was just a little thing that I wanted to share. Thank you for listening.
I've been getting instances of intensely beautiful smells as well. And it's hard to, it's not like it's from particular plants or anything in particular. There's just random times when it seems to come through when I'm driving. And it's the same smell. It's the same particular. It's a sort of a beautiful, sweet smell, almost sugary or something. But I can't explain it. But
Sure.
it's happening.
Well, of course. I mean, you taste the honey, and the person next to you, they've never eaten one. How would you explain the taste of the honey to the person? It's impossible.
Right, smells are quite difficult to describe. That is true.
Sure.
Okay. Thanks, Alper.
Thank you so much. Listening to you is just enlightening. Thank you.
Okay. Anybody else have anything to share here?
Well, yes, I have a light subject, just a simple, fun subject. If you have the time,
Mm-hmm.
if you've got the money, honey, I've got the time. Okay, what I'll need to do is screen share.
Okay.
And this is what I'll bring up. Remember when we were using our star formation as people to create our spaceship?
Right.
Well, this is an improvement on that, so that it has a flight control system. And so I only drew part of it up. And you can see the star formation of the people's. I didn't draw the chairs. They're sitting in chairs, and of course the center one, the top of the star is in a chair that's a little elevated, and so they can all swivel. And so you have, instead of 6 gravitational, you have 12 gravitational and 12 magnetical, and they're connected hand and foot. But also on further development of this, you have a gravitational group of people. Let me see if I'll just annotate here. You got a gravitational group of people here sitting in chairs and beyond, where they sit in chairs. This would be the opposite one another, and there's their head and shoulders, and their feet touch, and they hold hands. So you've got a gravitational here and a magnetical there, and you have 2 sets of these chairs around the ring. Of course, you'll have to probably set your star formation people out a little bit farther, and so now you've got a complete control system. You've also got another ring in here of people sitting. So you've got, just like the flight system that you saw Marco make and Vernie make. So now you've got the makings of the whole system there. These guys here have the easy job because they're just sitting on the floor, laying down resting. And this particular system comes from where you have the 12 people lying down and they're touching hand to foot. That comes from a actual energy system to send energy to others and to send energies to people. It's an actual exercise that people do. So this is not something that I just used a variation of that and put it into the flight system. And so now for the fun of it, you guys were talking about odors. You see, this individual here is affected by the odors. If someone actually has flatulence here, you see, the odor comes here, and this particular person on the top of the form, he smells it. He then pivots because he doesn't want to be smelling that odor, and that is what directs the flight system. If he pivots this way, if this person here has flatulence, then that's how the system is controlled. It's actually not controlled by the GANS of the mind, but it's controlled by the GANS that actually expels in the flatulence. So that's just a fun thing. But being a fun thing, it is also worth making an attempt to actually do it, where you have a group of people and you set them in these formations. You see if you can't create the whole flight system and the control of the flight system.
Well, that's an interesting control you have there. Well, you know, in one sense, maybe this could work because I hear in the old days where you'd have where a tribe would have a group cook. You know, the cook would cook for the tribe. When the cook cooks, then after the meal and smells flatulence, then they know what combinations cause that flatulence and so on. And if they're a good cook, they'll be able to change and modify their meals in order to accommodate the flatulence and, you know, prevent it or cause more, depending on what fun they're trying to create.
Yeah, I just brought that flatulence up in jest just for the fun. See, I had this prepared for our last day of graduation for the 1-year knowledge seekers, but they were all too serious. Nobody wanted to celebrate. So I only got to do a portion of it right at the beginning, and not very many people were in the group. Hadn't got into the class yet. So this is the whole flight system and the control system. You don't have to worry about nano coding or doing GANS because each individual is already set up for it. They all can. There's the feeding system and the health system. See, this group of people.
But what happens when you run out of beans?
Beans, yeah, that the flatulence is just ingest. That's too much of the matter state. but eventually you should run out of beans and run out of flatulence, and then it'll be easier to control the ship with the plasma of your emotions.
My question would be, who's steering? Trying to get consensus with any group of people is hard enough. Everyone will want to drive.
No, they're all, you got givers and takers, and that's the way it is in the world. There's a certain amount of givers at a certain amount of time, and you rotate from one time you're giving and another time you're taking, and so it would all work out.
How do you go up and down?
How do you get your ship to actually form a field around and also to lift?
Yeah, in the sort of perpendicular to that disk direction.
Well, what you've got is you have a failure to communicate here. I just draw the system and then I let other people figure out.
No, you got the answer. The center person's chair also raises and lowers. That's your control for the up and down, probably.
Yeah.
Yeah, if I can add here, it does not matter so much your physical position, since you will be able to control the strength.
Hey, you guys got to forget about I shouldn't even have mentioned.
Well, think about it though. The physical position does matter. If we raise someone up on a pedestal as such, and we have to look up to them, then that, they're elevated, and from our perspective, quite literally and physically. So perhaps that does make a difference. If that person was lowering themselves down below and you were already at ground level and they disappeared below you, that would be
this is another aspect of this.
That would give you a different sense, a different feeling.
It's interesting that up and down have sense compared relative to the Earth, or relative to the position of your own body. Where is your head and where are your feet?
Right. If everyone was upside down, then it would be all backwards that way, I suppose. So.
Yeah.
Well, in this particular,
if you are out of the space, up and down, you have to determine by yourself. You have to arbitrarily determine which is up and which is down for you.
Well, in this case, if the person that's raised in the center chair would be up or down relative to you who are laying down, that would be all that you'd probably need to relate to, in a sense.
See, here's a little star formation here. And all the inside people are female because they're the takers, and all the outside people are male. And the same thing with this on the ring, the inside people on these chairs, because there's a whole bunch of chairs around here, and you can get into the number state of how many chairs you want to put around. But then there's chairs. So the males are all out here and the females are on the inside. And so they're just hand in hand and foot to foot, this over here, and the same thing here. So now you've got all the power and strength that you need. You actually, you could control it by where if these people here have they got the spirit, they would then say we should go this way, and of course these three here, they're like a committee, and they'll say yes, and this one here will say I agree, and then they'll take off. You see, you might as well take it out of the plasma state and put it in the emotional state. Well, that was just a fun game. Now we got to get like, what is it? I figured it out, 144 people out here, because you can divide 144 by 2 so that you can have pairs, a man and a woman, one on each. And over here you could do 90, because you can divide that into 45 people, and you got your 9s and you got your 12. But you don't.
Danny?
Danny has you told about this 144 people. So may I just share my screen for?
Yeah, let me get out of here. This was just for the fun of it.
Well, you just raised another important point about the ladies being the creators and givers of life, as James mentions, as opposed to the takers and so on. So you're going to have to explain that one after Shandor gets done.
Purely sexual. I was purely sexual.
Well, no, this has come up before. But anyway, go ahead, Shandor, with what you have here. I think that's probably more
to share with those who haven't been at the one planet, one nation, one race event at Dubai. So you have to know the good news is that there were just the right number of people there. There were no more and no less according to the purpose. So it has been created the Universal Council of 12 as an expansion, as you see here on the drawing, around every dot which represents a person. There are 12 dots around, which created the Planetary Council, and that totals 144. So, and as I said, it was exactly the right number of people there, not more and no less. Rick is there also on the middle of the screen, you can see him.
Not sure how that happened, but there I was.
And the election was done by not by votes and by proposing somebody else, but everyone was elected by himself, by its own soul. So that it was needed to find person for each to represent speakers of each major language in the inner circle of 12 and around there were the other languages too. And if they were by accident 4 or 6 or 7 people who came for the same language, in case they had to hold their hands to stay in a circle, and that one who felt that there is another one in the circle who is better for that task, in that case he had to withdraw by himself until it reached to one representative for each language.
And did
So
people do that, Shandor?
So
So did people do that? Did they bow out kind of and allow someone to take over the reins as such? Or
exactly. It's so beautiful way of how to choose the right people. Let them choose themselves.
Yeah, I know Mr. Keshe had to explain that several times because it's kind of a new idea, as opposed to getting in a group and espousing your own attributes or trying to figure out who's the best. It was just they were told, I think, not to even speak about it. Right? They were just supposed to feel whether someone else was better than you for the job, essentially. So that's pretty cool.
Yes. I wish to share this. If you want to see more, just look at our Facebook pages, because we tried everyone who made pictures to share the pictures. If you go to my profile under my name, you can find some albums of photos which I was able to pick, and you will see among the other small pictures about all the event and all the environment, the beautiful, wonderful environment which was there. And also I put up some short videos about the gala event where you can feel actually the general emotion of the people. So all were very cheerful, enthusiastic, being happy of being there.
A lot of interchange and helping each other and teaching each other as well.
Yes, and if there were some little exceptions of somebody not so cheerful, you understood that it's not because he came, because he was brought there by his own soul, but he was brought there by another reason. So, for instance, we had a young man, I think from Austria, who finally it was found out that why he was not so happy, because he didn't come according to his will, but other people called him there because they needed him as an investor, and they promised him, oh, all the technologies will be demonstrated there. So they didn't inform him properly about what's the purpose of that conference. So that's why he was a bit not so happy at the beginning, because he expected some business-like activity for him to decide how much money to invest or not in manufacturing in a certain country. But finally, at the end, this cheerfulness became so enthusiastic that I think all were elevated to that good feeling. And if there were accidentally somebody who was not supposed to do the good things, they didn't show up at all. So all was fine, all was wonderful. Thank you very much for those who made that possible, especially for Caroline, who was up day and night just to take care of everything to be in the right place.
Yep, a lot of people worked hard for that event. Well done, Shandor. Thank you. Maybe we could get back to this question briefly before we shut off here. It's kind of left open, this, as Guy says, chicken and eggs dilemma. It's who is the giving and who is taking, and so on, with this idea that comes up, male, female, giving, taking, and it has to do with the plasma theory and plasma ideas on on the magnetical and gravitational aspects of the plasmatic interactions, I believe. And
actually, it doesn't matter male or female. One may be a giver or a taker according to his emotional level at a certain moment.
okay, well, that's a good point. So can we make any generalities about male versus female and for
I'd say
example,
definitely not. I'd say definitely not. So
there's what about the thing of for males the left hand is let me see
that's about the structure
giving
of
and
the
the right hand is receiving.
that. Yeah, sorry. That's about the structure, the specific structure of a certain body. How it works, and even that during the lifetime can change. You know, there are people who are right-handers or left-handers, and they may swap their hands, their main hand during their lifetime after they pass through some incidents.
I did. I had to use my right hand for about 2 years. I was forced from my family, and then I've written it. Really, I use it, and then I switched. Simply.
Thank you, Albert. So you are one of the examples.
Yes. May I just to give a little feedback from the Dubai photos? Am I allowed to talk about the photos? Because you all look like the movie stars in the photos. It was amazing. My heart was all the time with you. I was so wondering about what was going on and just trying to create many scenarios from the photos, thinking about you and Mr. Keshe and everyone. And your photos, Mr. Sandor, looked amazing. Every one of you looked amazing. I just wanted to say.
Yeah, thank you. That's the when you say we look like movie stars, it has only one single reason. That's the normal natural emotional tone of man. It's the cheerfulness.
Honestly, it was on the photo. Well, it's in front of me. There's no need to talk about it really.
Yeah,
it was just my personal thoughts. Thank you.
You see, if I want to see very many cheerful faces, I live in Budapest in Hungary, and there we have a street which is mainly for tourists. It's a walking street. And there you can find always tourists who are in their holidays. And because they are on holidays, they are so much well-feeling, very cheerful, very enthusiastic. And if you want to get a dose of high emotion, you just walk through that street. It's a different when you see tired people, overworked people who first they wake up at 5 o'clock and they take a coffee shop, and by 6 o'clock they are running to reach by 7 to their jobs and coming home, making their shoppings. That's a different lifestyle.
I understand
when it is free, it's cheerful. Believe me, trust me.
So true, sir. Yes, that's I understand it, and I also understand the culture that you just related to the feeling, and yes, I have experienced all this. I have done many different things in many different countries. So beautiful. Thank you.
You're welcome. Go to Cuba once, and you see people have their hard lives. They're working hard. They cannot buy whatever they want. They have such a ticket system that they have a limited quantity. They can buy half kilogram of sugar per month per person, or if your child is above 7 years, you are not allowed to buy milk. So you have to buy a goat if you still want to have milk. But you see all the people so cheerful, all smiling and happy faces. So we should learn from them. Or if you go to some countries of Africa, you see everybody smiles.
So true.
Even though they have no Hugo Boss suit and they have no Porsche car under themselves, they are feeling happy.
Yep, the more developed the country and more materialistic, generally speaking, the less happy the people are, according to the...
Yes, because they watch TV news.
Yes.
Which are specially designed in a way to keep people's emotional level low. Because
Well,
it's easier to control somebody at a low emotional level. They listen to what somebody tells them to do.
Also, the things of the material world that we treasure so much in our so-called advanced cultures is very tenuous at best, and it just doesn't give the satisfaction, the deeper satisfaction of the other types of activities, other places that attention is put, such as in feelings or group work and that kind of thing.
Yeah, so sometimes omit to need the news and switch off your TV and computer and just talk each to the other and to discover how beautiful are people around you.
Yep, or get in contact with more Keshe people that are enthusiastic instead of some of the other friends you might have that aren't. So, and then find ways to turn them on as well. Anyway, I think we have to wrap things up here. Thanks for the pictures.
Somebody was asking in the chat, unfortunately privately, that he's asking where to find the photos. So may I provide a link to some part of the photos, and for the rest you will find.
Yeah, you can check my Facebook, for example. Just posted a bunch of photos there. Caroline's Facebook, Shandor, Richard Ubik has all kinds of pictures. I've published some of the ones that, or shared some of the ones that he showed.
I just post here a link which is available also for those who are not Facebook members to find it, to let it find easier. Just don't forget to save your chat or save your link from the chat. I have to find a way to click to post it for everybody.
Right.
I think
okay, there it is. Yep, got it there. Thanks.
I have only a few others made 10 times more photos. Just I had little time to use my mobile phone to take some. Probably there will be others who will post later more photos, more selected, because I've seen that people with professional cameras.
Very good. Thank you.
You're all welcome, and thank you for making possible for us in so many years to come together once per week.
It's my pleasure, and I'm glad that everybody's participating. And it's interesting tonight, especially. We seem to have clicked on, one subject after another seemed to mesh together, kind of, and we're all sort of working on the same thing from different angles and so on. It's interesting. So, very good. Okay, I'll wrap it up for today's Plasma Reactor group. Thank you, everybody, for attending. Sorry
Thank you so much.
Get back to you, Mario, there, but I guess you'll have more for us next week anyway, so we'll carry on. And, yeah, thank you, everyone. So,
thanks, Rick. Thanks, everybody. Good night.
Okay, thanks. And I'll end the live stream.